Now we're going to look at how to use N, P, and Q to find some situations without generating a full table. Sometimes you don't need to know individual probabilities. You only want to know the mean and the standard deviation and most likely the usual values. And so we have these crazy formulas, but we can make them a little bit neater. So if I want to talk about the mean, that is the number of trials times the probability of success. This can still be called the expected value. Variance is N times P times Q. In all likelihood, you don't want to know the variance. You want to know the standard deviation. And so that you would take the same, take the square root. Now we're going to use the same range rule. Sometimes it says use the range rule by taking your min and your max and dividing by 4, but also you're going to use the same rule for usual values where that it'll be 2 up and 2 down. So back to the pea pods, right? 75% chance that they'll be green, and Mendel generated 580 peas. He claimed that the 435 would have green pea pods. That's 75% of 580. When he actually did the experiment, he got 428. So assuming that groups of 580 are generated, find the mean and the standard deviation, and then use that range rule to talk about whether or not 428 is unusual. So N times P, N is 580, P is 425.75. So 435 is our mean. They kind of said that in the storyline already. But they did not talk about the standard deviation. So I say N times P times Q, take the square root. The storyline will tell you where to round, and I get 10.4. So 10.4 twice, add that on to the mean, you get a high end of 456, we'll say. And then if I subtract 2 standard deviations off, then I'll get 4.14-ish. And so my usual range of values, if I do this experiment many times, with 580 pea pods that I'm planting, I can expect somewhere between 414 and 456 of them to be green, given that 428 is a usual value. That is not something that raises any kind of concern. And so you have a couple of these guys in your homework. And we'll look at one of those now. Several psychology students are prepared or unprepared for a surprise true and false test, right? So staying with binomial, it's either true or false. There's 13 questions. Find the mean and the standard deviation. Well, if it's binomial and each one is likely, so it's true or false, and either you know it or you don't, and we're going to assume that this is a 50-50 shot. 0.5 times 13 gives you a 6.5. Your expected value does not need to be possible, right? And we know you can't get a 6.5 on a multiple choice test or a true and false test, right? You can't get half the question right, but that doesn't mean that that's not an expected value. Just like for a long time they said that the expected number of children a couple would have was like 2.3 or something like that. Now let's find our standard deviation. P times Q times N, the order does not matter. And then I need to take the square root. And I get 1.8. Would it be unusual for a student to pass by guessing? Well, let's find out. 9 is considered passing. So 1.8 times 2, let's add that on to my mean of 6.5. All right, so 9's in the high end. If I subtract that off, well, I guess I need to do it this way. It's a 2.9. So 9 is in the range of usual values. Would it be unusual? No, it would not be unusual because 9 is within the range of values. So yes, it would be usual. No, it would not be unusual. Sometimes it's a little tricky. You have to read those questions a couple of times because they ask things backwards very often in stats. Use the other calculator trick video for some of your other do's and don'ts and things that you can do in your other sections.